It is a delight to be with you in class, great thinkers. In this class, I will be teaching you the topic logical reasoning, the concluding part of my lecture series. Recall in the last class, I taught you negation and conjunction. In this class, I will be teaching you the remaining logical operators. And so by the end of this lesson, you should be able to do the following. You should be able to prepare truth tables involving the logical operators, disjunction, implication, and biconditional statements. You should also be able to solve problems involving the logical operators, which are disjunction, conditional statements, and biconditional statements. So the first logical operator I will be teaching you is the disjunction. The disjunction is a compound sentence of two propositions joined by the word or. So whenever you see or joining two statements or proposition, you know that it's a disjunction. The V shape is used to represent the disjunction, the logical operator disjunction. So let's take a look at how the truth table, the Venn diagram representing disjunction looks like. The Venn diagram of P disjunction Q is the union of two sets P and Q. And so the union of any two sets represents the disjunction of that set. So let's take a look at the truth table involving the logical operator disjunction. From the table above, you will see that it is always true. The only time it is false is when the first statement is false and the second statement is false. So for a disjunction, the rule that governs it is that the only time a disjunction is false is when the first statement is false and the second statement is false. Otherwise, it will always give you a truth outcome. Let's take this example. Use P, Q to represent the statements below and express them symbolically. The man ate yam or beans, and the man is old or the woman is not young. So what we are going to do, we'll take the first question, which is the man ate yam or beans. We are going to represent it symbolically. So let P represent the man ate yam and Q beans. Symbolically, we can represent these statements with P disjunction Q, where P represent the man ate yam and Q represent beans. So symbolically, it will be P disjunction Q. The next solution we are also going to look at is the man is old. We use P to represent that, and the woman is young represents the second statement. So symbolically, the second statement, which is the man is young and the woman is old and the woman is not young, will be P disjunction negation Q, where the Q statement was negated. So it will be P disjunction negation Q. So let's prepare a truth table involving disjunction. On your screen, you are told to copy and complete the table below. You have about 4 columns. The first column is made up of truth, truth, false, false. While the second column, you have truth, false, and then you also have truth, false. So we are going to negate the column for Q, and then we will now subsequently find P disjunction negation Q. So let's negate the column for Q. Because the first statement is true, the negation of that first statement of Q, which is T, will be false. And the second statement is false. So the negation of that statement will be true. So for the first 2 columns for negation Q, you are going to have false and true. So for the last 2 statements, you have truth and false. So the negation of T will be false, while the negation of F will be true. So in the last column, you have F and T, false and true. So we are now going to take the disjunction of the first row with the third row, which is P disjunction negation Q. So when you compare them, you remember a disjunction is only false when both statements are false. So the first 2 columns will still be true because one of them is true, the other one is false. But in the third column, you have false there because the 2 statements are false, while in the fourth column you still have true because the first statement is false and the second statement is true. Remember, a disjunction is only false when both statements are false. So the next logical operator we'll be taking is the conditional statement. A conditional statement is of the form if P then Q, where P and Q are different propositions. The arrow sign is used to represent the conditional statement or the implication. For a conditional statement, the first part of the statement is called the antecedent, while the second part is called the consequence. Let's take a look at the Venn diagram that represents a conditional statement. You will discover that the smaller circle is a subset of the larger one. So for instance, if you live in Boston and the first statement, and the second statement you live in Massachusetts. So we all know that Boston is a city in Massachusetts. So it will be, Boston will be a subset. You live in Boston will be a subset of you live in Massachusetts. The truth table for a conditional statement is what you see on your screen. You will observe that the only time that you will see a false outcome for a conditional statement is when the first statement is true and the second statement is false. Otherwise, you will always be having a truth outcome. So I want you to take note. It will be safe to conclude that for a conditional statement, the only time P implies Q will be false is when the first statement is true and the second statement is false. So let's take this question. Given the statements P is equal to the boss comes late and Q, I will take a taxi. Write a compound statement that describes P implies Q. So we are going to take that conditional statement, which is P implies Q. So we are going to write it. So P implies Q will be, if the boss comes late, then I will take a taxi. So P implies Q will be that. So let's prepare a truth table involving conditional statements. It has about five different columns. So in the first one, we have already prepared a truth table for P implies Q. Remember that the only time P implies Q will be false is when the first statement is true and the second statement is false. So the first two rows will give you a truth outcome, while the third row will give you a false outcome because the first statement is true and the second statement is false. So we go to the next column, which is Q implies P. This time around, Q will be the first statement while P will be the second statement. So false will still give you true, while true-false will give you false. False truth will still give you true, while truth will still give you true. So for Q implies P, you are going to have T, F, and T, T. So we are going to take the conjunction of the last two columns there, which is P implies Q, conjunction Q implies P. Recall in the last class, I told you that for a conjunction, for it to be true, the two statements will have to be true. So in the first column, you have truth, so the outcome will be true. While in the second column, you have truth, false, so it will be false. In the third column, you have false, truth, you are still going to have false. While in the fourth column, you have true, so you have true. Because a conjunction is only true when both statements are true. Otherwise, you are going to be having a false outcome. Implication is not the only conditional statement we have. So let's just look at other conditional statements. The first one is the converse of a statement. The converse of the conditional statement, if P then Q, will be if Q then P. Mathematically, this can be represented by if P implies Q, which is the original statement, that means that Q will implies P. So for the converse of a statement, P implies Q will be Q implies P. The second one is the inverse of a statement. The inverse of the conditional statement, if P then Q, will be the conditional statement, if not P, then not Q. Mathematically or symbolically, you can represent this. P implies Q. The inverse of that statement will be negation P, implying negation Q. That will be the symbolical representation of that statement. The last other conditional statement we'll be taking is the contrapositive of a statement. The contrapositive of the conditional statement, if P then Q, will be negation Q implies negation P. Take note, So if you have the conditional statement P implies Q, the contrapositive of such a statement will be a negation of the reverse order, which is negation P implying negation Q implying negation P. So let's take this question. Give the converse, the inverse and the contrapositive of the statement. If a figure is a square, then it is a quadrilateral. If a figure is a square, then it is a quadrilateral. So the converse of this statement will be, if a figure is a quadrilateral, then it is a square. So remember that the converse of any statement of P implies Q will be Q implies P. So if a figure is a quadrilateral, then it is a square. The inverse of the statement will be, if a figure is not a square, then it is not a quadrilateral. While the last one is the contrapositive statement. So let's take the biconditional statements. The biconditional statements are statements joined by the word if and only if. They are sometimes referred to as the equivalent statements. So, and the symbol you use to represent them is the double arrow sign, the double arrow symbol. Let's take a look at the truth table involving biconditional statements. You can see that the only time a biconditional statement is true is when both statements are either true or when they are false. Otherwise, you will always be getting a false outcome. So we can take note that for a biconditional statement, the only time it is true is when both statements are either true or when they are false. Otherwise, it will always give you a false outcome. So let's take an example to concretize. The table is divided into 5 different columns. And you have P implies Q in the first column. In the third column, you have P disjunction negation Q in the fourth column, and then you are told to find the biconditional of those two statements. For P implies Q, we've already done that before. And so remember that you are going to have truth, false, truth, truth. For P disjunction negation Q, remember that a disjunction is only false when both statements are false. And so you are going to have truth, truth, false, truth. And then you now take the biconditional of those two statements, knowing that a biconditional statement is only true either when both statements are true or when they are false. So truth, truth will give you truth, false, truth will give you false, truth, false will give you false, and truth, truth will give you true. That is it for today's class. I'll see you next time. Bye-bye.